All right, so I want just to finish the topic of the impact and, the impulse and momentum. We have not much. We are just gonna solve one problem, but it's a really important concept, but I wanna go through what you have in your memory from last time. Do you guys remember the general equation of the impulse of the momentum? Anything? I'm not sure if I have a review for the second exam, but maybe I will check if I have something. All right, do you guys remember? It was the summation of the momentum before plus the impulse. Like if you have a body and this body was here and is moving with a velocity v1 and it has a mass m, so it has an initial momentum, and this is the final momentum mv2. But this body got impacted with an impulse, which is a force dt from 0 to time t. The initial momentum plus the impulse acting on this body equal to the final momentum. That's the general rule that we had from before. Impulse plus momentum is going to give you the final momentum. That's what we have here. The thing is, we take this concept to the next level. And by the way, when you get in the exam and I give you a question that has only velocities and time and forces, that means that you have to use the impulse and momentum. Maybe I will not tell you, but everything is given to you. Time, velocity, mass, forces, everything in the equation is given. So all what you have to do is to figure out where to put the numbers that I give to you in this equation. But let's say I give you distance. Distance doesn't fit here. When I see distance, that means it's work. It's force multiplied by distance. So you have F and S, that means work and energy. You have F and time, that means impulse and momentum. Unless you are gonna convert the time into distance. How? You are given velocity and given time, right? So if you're given velocity and time, somehow you can convert these two and get the distance, because the relationship between velocity and time, V equal to the time rate of change of the displacement. So you can convert that, but why would I should do that? Like, you're already given time and you're given velocity, right away substitute in this equation, okay? All right, so this is the general equation of the impulse and momentum. And then we talked about something is called impact. If two bodies this is just one body, okay? But if you have two bodies are gonna have a collision, like something like this. We talked last time that this collision, this body is gonna act a force on this body, and this body is gonna act force on this body. Okay, like this one is gonna make an F, and this one is gonna have negative F, all right? But if you wanna take everybody separately, this one and this one is gonna have negative F impacting him, and this one is gonna have an F impacting something like this. So body number one have F on body number two, and body number two have negative F on body number one. But there's a concept that we talked about, that there's a conservation of energy at the whole system. How this happened? The thing is, this one is gonna have an impulse of F dt, and this one is gonna have an impulse F negative F dt. So when you put the two systems together, the two impulses are gonna cancel each other, and we are gonna end up with, like here, this F is gonna be canceled, and we are gonna get the summation of the momentum before equal to the summation of the momentum after. Why? Because the two impulses cancel each other, but this only happens if you take the two body under consideration. But if you take one body separately and looking at this body, its equation is going to be summation of the mass mv1. Let's say this body is going to be minus the integration of f dt, the summation of the mass v2. And this only applies for this body. Okay? Did you guys get that? But here's the masses. You are going to have two terms. You have this body and this body together at the same side. You have m1 multiplied by V1 plus M2 multiplied by V1 of each body, and here's the final velocities of the two bodies. Does anybody have any question? We explain this in details. It's nothing new here. All right. And if you guys remember, when impacts happen, the conservation of momentum happens at the line of impact. We call this the line of impact. The line of impact is where the forces are acting with each other. Like you cannot do conservation of momentum at this line. This is the line of contact. Doesn't have any forces. The forces are at the line of impact. Like let's say I give you these two bodies like this. Not like this. So basically, this is the line of impact. And this is where there is conservation in the momentum. Because we impact each other. This is the line that we have conservation, or this is the line that has the forces cancel each other. Okay, so you have to understand this. All right, like let's say I have a wall like this. And you have a body is hitting the wall something like this. And then your ball is here. Okay, so basically the line, the line of impact is this line. And the line of contact is this line. So this is where there's conservation of linear momentum. And at this line, you can apply this rule. So all the velocities have to be in this direction. All the velocities have to be in this direction. Let's say that I give you the velocity in x and y. So you have to find the velocity at the line, like the summation of these two, at this line, so that you can apply this rule. We are going to find out about this solving a problem. But let me finish the rules that we have from before. Do you guys remember that we have something called E? Do you guys remember what E is? It's a coefficient of something. It's called restitution coefficient. So it basically tells you how does the impact look like. Like it's elastic. Do you guys remember something like this? And that's happened because when two bodies hit each other, the thing is they have a lot of forces. Okay, so they have the impact each other with force B, but when they leave each other, they leave with different force. It's called restitution force. So there's an impact force and there is restitution force. The relationship between them is this one. If the restitution force leaving each other is equal to the one that hit, that means that they didn't lose anything. That means that's a perfectly elastic collision. They didn't lose any of these forces. And if that happened, let's say, you guys have seen this game that you have like a bunch of balls and they are hanged, and then you take one like this and you keep going like this, and they might be going forever, they don't stop. That means they are nearly elastic. They don't lose the forces. They are gonna stop at some point, but it takes some time. Okay, so maybe the restitution coefficient is 0.95 or something. So they keep going forever. But let's say if these balls are not metal, like rubber, and they keep like they are not gonna last forever. They are gonna make 3 rounds and they're gonna stop. Okay, so that's what the restitution coefficient tells us. So the restitution coefficient, if you remember, it's the integration of r dt over the integration of b dt. If you remember, r was the restitution force and b is the impact force. And if r equal to b, that means it is an elastic system. And there was multiple values for E, but we able to prove that E is equal to V2 of body number B minus V2, let's actually make VB, like if you have body A and body B, and they are having a collision. VB final minus VA final over VA initial minus VB initial, that is E. Okay? If you look at the notes, you will find where we got this from. That is the value of E. Sometimes in some problems, I'm going to give you E. And some problems, I will say it's elastic collision. If it's elastic, that means E equal to 1. If it's a 0, that means, so sometimes I don't have to give it to you. I just say a word elastic, so you basically put E equal to 1. If it's elastic, I put E equal to 0. Yeah. Do you have any question?
Yeah, what was that called again? Like the name of
this?
Yeah.
Restitution coefficient. Okay, so that's E can have multiple values, can have a value of 1, can have a value of 0, and sometimes there is no body B. So value of 1, that means it's elastic collision, and 0 is elastic, and there is no body B, that means VB is equal to 0, and VB1, like I have a wall, like this. This body is not moving, and just body number A that is moving, and if body A is moving, so you have VA2 and VA1, and VA2 is the velocity that this body was hitting the wall with, and VA1 is the velocity that you were hitting the wall with, and when you leave the wall, that is VA2. B, body number B, which is the wall, VB2 equal to VB1 equal to 0. So if there's no body B, the restitution coefficient is going to be equal to negative A2 over VA1. Just make sure about this. Like sometimes I give you in the exam, I tell you we have a basketball is going to hit an inclined wall. Once we say wall, that means there is no body, the body B is not moving. So I will not tell you that the body B is not moving, or I will not tell you that VB2 and VB1 is equal to 0. You have to figure it out yourself, okay? Are we all agree on this? All right. And sometimes I will not tell you what is the value of the restitution coefficient. I can tell you elastic, so you basically know elastic, that means E equal to 1, or elastic, that means it's equal to 0. That means, if you guys remember elastic, that means that R equal to B. The force when they hit each other and leaving each other are equal to each other. But sometimes R is equal to 0. They hit each other with a big force, but after this, they still together. They stop. They don't go away from each other. So at this moment, R is going to be equal to 0, which will make the restitution coefficient equal to 0. Okay? All right. So that's a quick revision on what we have done the last 2 lectures. So let's see what we have this lecture. The impacts that we have done before, it's called linear impacts. What is linear impact is that the velocities of these bodies in the same direction of the line of impact. Okay? But let's say that we have X. What we are going to do right now is called leap impact. All right, let's say that we have these 2 bodies, okay? If these 2 bodies were like impacting each other with velocities, and the y-axis is gonna be linear impact. But the thing is, this ball was somewhere here before the impact, and this one was somewhere here before the impact, and then it moved with a velocity in this direction, okay, and this one moved with a velocity in this direction. Let's say that this is body A, and this is body B, and this is VA1 before the impact, and this is VB1 before the impact. Tell me, okay, let's ask that question in a different way. These 2 balls are hitting each other, and the velocity are in the y-axis. After the collision, where they are gonna go? In the same direction, like in y-axis, right? This one is gonna go that way, and this one is gonna go down, because they hit each other with velocity vertical. But if the balls are moving with inclined velocity, like this and this, how do you think these 2 balls after the impact is gonna go? They are gonna spread from each other. This one is gonna go that way, and this one is gonna go that way. If you really master this subject, you will be very good in like these games, like when you where to hit the ball, where to direct the ball. Anyway, okay, so I have this one is gonna go with a velocity VA2, and this one is gonna go with a velocity VB2, and somehow this ball is gonna be here. That's after the impact. That is called oblique impact, all right? Because the velocity is not in the same direction of the line of impact. This is what we call the line of impact. By the way, the first thing that you have to do in any impact problem, you have to define or quantify or find out where is the line of impact. The line of impact is the one that has the forces. This one is going to have a force here acting on this body, and this one is going to have a force here acting. Right? Okay, so let's see how we can let's analyze this. I'm gonna put this here. I'm gonna put body A and body B. Let's say that this is body A and this is body B. Body A has a velocity VA1 like this. This is A1, sorry, let's say VA1, the initial velocity. And this one is having VB1. So let's look at the momentum, at the components of the momentum. So this one is gonna have a component in this direction, and it has a component in this direction of the momentum, right? Because the velocity is inclined. So I'm gonna have here MVA1 in the x direction. And I'm gonna have here MVA1 in the y direction. Same thing, this one is gonna have MVB1 in the x direction and MVB1 in the y direction. That's before the impact. And then, when they are gonna have a collision, everyone is gonna impact the other one with a force. So let's put the forces here. All right. Can you see this force? This force is going to impact this body, and this force is going to impact this body. So what we are going to have here, this one is going to have a force like this. And this is the integration of F dt. And this one is going to have a force like this, and this is the integration of F dt. Everyone is taking force from each other. Then, if you plus the momentum with the impulse, it's going to give you the final momentum. Sorry, this is going to be equal. This body, after the impact, is going to move that way, and this body is going to move that way. That is VA2, and this is VB2. So, you are going to have a momentum in the x direction is going to be MVA2 in the x direction, and here you are going to have MVA2 in the y direction. Same thing here, MVB2 in the x direction, put x here, and here you are going to have M. By the way, let's say that this is MA and MB so that you guys know that this is body A, and this is body A, and this is body A, and this is body B. And here I'm going to have MVB2 and the y direction, right? So that's actually all the impulses and the momentums that are acting at the two bodies. All right, let's see how we can use this. By the way, let me ask you, where is the impulses happening? At what direction, y or x? There is momentum in x and y, but there is the impulse is only in one direction, in the y direction. Excellent. Here, this one. So this is the direction that it has the force. This is where I can put the conservation of momentum, because this is where the forces or the impulses is conserved. There is no forces in the x direction that can be conserved. So this one that has the conservation of momentum. And that's why I can apply at this line, I can apply the rule, this one, and this one. This rule, the summation of the momentum before and after, and this rule, the E rule, because the E rule is coming from the conservation of impulse and momentum before and after. Okay, so let's see how can I write these rules. Let me write them in black. The first one, let's look in the y direction where, let me write it here, in y direction. What happens in the y direction? Let's look at y direction here. What do I have? Okay, I have this and this, and I have this too, and I have this and this. Let's sum all the impulses and the momentum before and after. So before, I'm gonna have MA VA1 in the y direction plus this one MB VB1 in the y direction plus these two forces. If you plus this and this, it's going to give you 0, right? Because they are equal to each other. And this is going to be equal to the left hand side. What do I have in the left hand side? In the y direction, MA VA2 in the y direction plus MB VB2 in the y direction. That is the first thing that I got. Like I summed everything in the y direction, before and after, because it's one system. So these two are gonna cancel each other, okay? So that's the first thing. And the second equation that I have is the restitution coefficient. The restitution coefficient applied also for the entire system. And the restitution coefficient is also only happens in at the line of impact. Why? You guys remember when we have RMB? The RMB is the forces that act on the bodies, and these forces only get generated at the line of impact. It doesn't happen in the x direction. So be careful with this. E only applied when there's forces, and this only happens in the y direction. So E, when you put velocities, these two, before I didn't care if this velocity in x and y. Why? Because the impact happened in one direction. There is no two direction. There is no x and y. But right now you have to be careful. Why? Because I have this rule VB2 minus VA2 over VA1 minus VB1. That doesn't work here. Why? Because VB right now has an x component and y component. So you have to decide which velocity components that you are going to put in this rule. And the component that you are going to use here, it's the component in the line of impact. So since the line of impact in the y direction, so this all need to be y. Y, y, y. If you put it x, that is going to be a fatal mistake. Everything is going to be 0. But let's say if we reverse this problem and we are going to hit each other in the x direction, so you are going to put x direction, okay? Let's say that I give you an example like this one. So if you want to apply the restitution coefficient E, you have to find the velocities in this direction. Like let's say that this ball is falling from up there, from here, and this is the velocity. You have to get the component in this direction and the component in this direction. And then you are going to use the component in the direction of the impact. The one in the same direction of the line of impact. We are going to solve a problem like this. Just for now, make sure that the restitution coefficient is going to only work for one axis, either x and y. And you pick it based on where is the line of impact. Here, my line of impact, where is the forces, is the y direction. Okay, so that's equation number 1, and that's equation number 2. How about equation number 3? Equation number 3 is very easy. I will look at the other direction, the x direction. Okay, for x direction, look at this. X direction, I only have momentum in x and momentum here in x, before and after. Okay? So basically for this body, I can take every body separately. Like I can take this body and I say the summation of the momentum in the x direction before and after. There is no forces here. So MA VA1x equal to MA V2x. MA VA1x is going to be equal to MA VA2x. And MA is equal, that means that the velocity A1, VA1x equal to the velocity VA2x. That the velocity in the x direction before and after is the same. The only one that is changing is the y direction, where is the impact.
Does the direction matter? Does the direction matter?
What do you mean by the direction matter?
Because both are going to the same direction.
This one and this one?
Yes.
Yeah, they are x directions.
And you add them up and put them to zero, or just
No, the thing is there's state before and a state after.
oh.
So the velocity in the x direction, which is not the line of impact, because the thing is, the forces is the one that only changes the direction. Okay? So since all the forces in y direction, so basically the force is changing the velocity in the y direction. Does not it change the velocity in the x direction? Or we can say that the impulse is in y direction, so it impacts the momentum in the y direction, doesn't impact the momentum in the x direction. So basically, we can say that the momentum in the other direction before and after is equal. It only gets changed in the line of impact. Alright, so this is the equation, same thing for y. For body B. VB1 in the x direction is equal to VB2 in the x direction for body B. Alright? So this is the main equations that you need in impulse and momentum. That's all the equations that you need to solve any problem. So let's actually put a problem and try to solve it. And sometimes I would give you a problem that you have to use some other concept, either the chapter 12 or chapter 3 or chapter 14, to get some other component that help you in the impulse and momentum, which is similar to the one that I'm going to do here. All right, so this problem says that you have a 0.5 kilogram mass dropped at 1 meter from rest on a surface of E equal to 0.75. What is the post bounce velocity expressed in tangent normal components? All right. I have a surface. I give you a surface like this, and I told you that this surface at an angle theta, I didn't give you the theta, but I give you that the horizontal is 3 and this is 4. So it's easy to get the theta. And somehow there's a mass here m equal to 0.5 kilogram is dropped at elevation 1 meter, like the distance here, this distance, until it hits here. Alright? This distance is 1 meter. And this is the surface that this body is going to hit, right? Okay. And for example, we can, I'm not going to say that, it's going to solve the problem. And I told you that we have tangent normal components, and this is the normal, the surface, and this is the tangent to the surface. I'm asking you the post-bouncing velocity expressed in tangent normal components. So I want to know what is the final velocity of this body gonna look like. All right, the thing is, the body started from rest here, okay? So, you think I put VA1 is equal to 0? Like, okay, right now we are gonna use these equations, right? These equations, but we need to have velocity before and after, right? So I wanna know the velocity before the impact and the velocity after the impact, okay? So I have, this is my surface, and the ball is gonna, I'm gonna leave it like this, and it's gonna hit this surface. But I wanna ask you, what is the velocity V1 and V2? The velocity V1 is the one right before the contact, and V2 is the right after the contact. So when I leave the velocity at V equal to 0, this is not the contact velocity. So when you leave the body, the velocities keep getting increasing because the acceleration keep getting increasing because of the ground acceleration. So the thing is, you need to find what is the velocity right before the contact is. Can you guys do that? Can you guys find the velocity right before the contact? Do you know what we should use to find this velocity? If you know the initial velocity, what concepts that we should use? I have a body elevated from the ground. Let's say that this is the datum. You have a potential energy here, and kinetic energy is equal to 0 because it starts from rest. The thing is, when it gets to the datum, it's going to be 0 potential energy, but it's going to have more kinetic energy. Do you guys remember that? So we can use the concept of work and energy, or the conservation of energy. Like, do you guys remember mgh node, or h1 plus half mv node square is going to be equal to, let's say that this position is O, and right before is 1, and right after is 2. Okay? Because we are interested in 1 and 2, before and after. But actually, the ball is like up there at 0. So we want right after the impact. So basically, if I assume that this is the datum, actually you can assume the datum up there. Whatever you like is going to give you the same answer. But if I say that this is the datum, so this is have positive potential energy to go down, like mgh, but have 0 kinetic energy because the velocity is 0. And then the final is going to be mgh1 plus half mv1 squared. So let's find out. Here, I know that this is equal to 0. There's no kinetic energy because it starts from rest. And here, the potential energy is 0 because the body, when it comes from here, down here to the datum, has 0 potential energy at the datum. It has positive potential energy above the datum. It has negative potential energy below the datum. Okay? All right. So I have mgho, so I have m is equal to 0.5, g is equal to 9.81, and ho is equal to 1 meter. Plus 0 equal to 0 plus half multiplied by 0.5 multiplied by v1 squared. One equation, one unknown, you can get v1 equal to, before the impact, this is going to be equal to 4.429 meter per second. By the way, you can get the velocity by many different ways. You know this distance. You can say that the acceleration ADS is equal to VdV, and then you integrate this and this. You know S, you know that A is equal to G, 9.81, because that's the acceleration of the ground. You know the velocities before 0, so you will still also end up with, so this is going to be A multiplied by S, or G multiplied by S, because A is constant, you can get it out. It's going to be equal to half V1 squared minus v e naught squared, then you can get the final velocity. Same thing. Like here, look at this. This is the mass, 0.5, and you have here 0.5. So they are gonna slash each other. So you will end up with 9.81 multiplied by s. Here, 9.81 multiplied by s. And here half mv1 squared minus v naught squared. Here half 0.5, which was already slashed, and you are gonna end up with v1 squared. Same concept. Work and energy is gonna work. Kinematics is gonna work. So all what I need to know what is the velocity right before the impact. You got the velocity right before the impact. Let's find the velocity post bounce after the impact. Okay, let me ask you, what is the direction of this velocity? This is v1. Actually, if we are talking x and y, and let's say that this is the y direction, so all the velocity are in the negative y direction. So actually you can write v1 is equal to 0 and the I hat plus, but here is going to be minus 4.429 in the j hat direction, right? That's an I j hat direction, right? Okay. All right, so I have v1 is in this direction, but the impact happens, this is the line of contact. Can you see? I told you we always need the line of contact, where the force is going to happen. Here's you're going to have force, and here's you're going to have force. So we need to find what is the velocity in this direction. Okay? It's like this is our y here. Can you see? This is our y, but it starts to be something like this. Like we shifted the impact like this. That's why we need to convert these velocities, one in the n direction and one in the tangent direction. Okay? So let's take this here. I'm gonna erase this. All right, let's say that this is my surface, and this is my point that I'm interested in, and this is v1. All right, this is the tangent direction. Sorry, this is the normal, and this is the tangent direction. All right. The angle. If I said that this is angle theta, and this is 3, and this is 4, can you guys tell me what is the sine theta is equal to? If this is theta, this is 3, this is 4.
4 over 5.
4 over 5. What is cosine theta?
3 over 5.
3 over 5. All right. So if this is theta, what is this angle? Theta. And what is this angle? Theta. So I know where theta is. So right now, if I want to find the velocity v1 in the tangent and normal direction, can you guys tell me? This is v1, it's in this direction. Can you tell me what should I put here? I want in the t hat plus something in the n hat direction. I try to find what is the component of the velocity in this direction and this direction, right? So what is the component in the n hat direction? v1 cosine or sine. This is the v and this is theta. So v1, I want to find the component in this direction, the n, and component in the tangent direction, which the extension of this direction. v1 is going to have a component like this and component like this, right? Two components, and this is theta. This is Vn and this is V tangent, right? Vn is going to be equal to V1 cosine theta. So you are going to have here the tangent direction is going to be sine, so you are going to have V1, which is 4.429 multiplied by, this is the sine component is in the tangent direction, so this is multiplied by 4 over 5, and this is in the tangent direction positive, because it goes down there. This one is a negative in hat direction, which is going to be 4.429 multiplied by 3 over 5 in the n hat direction. Do you guys know how did I got that? It's a velocity v is coming this way. I want to get the component in this direction and this direction. If this is theta, this is v cosine and v sine. Right? Okay. So I got v1. Why did I do that? Because I want to know what is the velocity at the line of impact, because so that I can use these rules that I told you about. Okay, so right now I got V1, one component in the tangent, one component in the normal direction. Alright, so when the impact happened in this direction, okay? And the velocity that this body hit with was something like this. That's V1. I expected that V2 is gonna be something like this. That's what is gonna happen, how this ball is gonna move, alright? The more that this surface is gonna be like this, when you leave the ball, it's gonna come back to you. But if it's inclined, it's gonna go somewhere else. Alright, I want to find what is the value of V2. To do this, I have to look at the XY components here. Alright, let's substitute in E, number 1. Why I'm gonna substitute in E? Because I already gave you that E is equal to 0.75. So I can here write the equation of E is gonna be equal to, we know that equal to V2, body number 1, let's say V2, body number 2, V2 minus VA2 over VA1, VB1. But this happens if the impact is linear. Right now the impact is not linear. The velocity is in different direction from the line of impact. So you will tell me what should be the direction of E. Should be the E in the n hat direction or in the tangent direction? Where's the impact is happening? In the n direction. So all these need to be n. Here. N, 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 N. Alright? So you have to define where's the impact is happening, and here we put the direction of the velocity. Okay? The impact doesn't happen in the tangent direction. Impact happens in the normal direction. Okay. But do you guys remember when I told you if you have a surface, the velocity of the surface is 0? So I have body A have a velocity, but body B should be 0. The second body, right? So if you have V is equal to 0.75 and VA2n hat, I don't know it, so I'm gonna put negative VA2n, and here I'm gonna have VA1n. VA1 is already negative. It's negative 4.429 multiplied by 0.35. So this is gonna be negative VA2n, and here you're gonna have negative 4.429 multiplied by 3 over 5. And you multiply 0.75 by this, you will find out that VA2n is equal to 1.993, and it's positive meter per second, and this is in the n hat direction because we only are getting the n hat right now. Okay, that's number 1. Right, so right now we got the n hat direction because that's the line of impact is equal to 1.993. Let's get the tangent direction. The other direction, if you guys remember, here is the equations that we got from the line of impact in the y direction. Then the x direction, the velocity doesn't change. So the velocity before is the same like the velocity after. So here I can say that the velocity VA2 in the tangent direction equal to the VA1 in the tangent direction. Why? Because that's the line that doesn't have an impact, and this is gonna be equal to 4.429 multiplied by 4 over 5, which is this component. And this is gonna be equal to 3.543. 3.543 meter per second. And this is in the tangent direction. So the final velocity VA2 is going to be equal to 3.543 in the tangent direction plus 1.993 in the n hat direction. That is the final velocity that I asked for, the post bounce velocity expressed in tangent and normal component. Let's revise this very quick and see what did I do. Number 1, step by step. I give you a body is gonna bounce on a wall. First, you have to find what is the velocity before. So I use the concept of work and energy, or use the concept of dynamics to get the velocity right before it hits the wall. That's VA1, okay? So I found the value of this velocity. Second is that you have to determine the line of impact. If I give you a surface like this, and a ball is gonna hit this surface like this, that's oblique impact, not linear impact, okay? Because it have a velocity in X and Y. But if I give you a body's moving like this, it's gonna impact the surface, that's a linear impact. It's a very easy problem. So if it's linear impact, it's gonna be like the problems that we solved before the break. But if I give you one that is moving like this, or they are not linear, they are oblique, so you will have to figure out where is the line of impact. Here I found out it's in the normal direction, and the tangent direction is not the normal, is not the line of impact. Here I found out it's the y direction. Then you have these two equations, where you set these two equations, you have to figure out what axes that you should put here, y or x. For these two equations, just write them without y, okay? Just write them general, MA, VA1, and MB, VB, whatever, without the axes, and then look, where is the line of impact? Is it x or y? Oh, that's y, so I'm gonna put y here and y here for these two equations. And this is the other axis, it's gonna be x. So write these three equations in front of you, and just figure out which axes you are gonna put. Depends on the line of impact. Here I did the same thing. The impact is the n direction, and here I already have the velocity, a component in the tangent and component in the normal. Okay? So the normal direction is gonna be the one that I put the restitution coefficient, and the one that I'm gonna use for the one that I'm gonna use for the x, or the other direction, is the tangent component. Okay? All right, so what if I ask you to convert the velocity that you got, and by the way, I got the velocity is in x, is in y direction, so you will have to use the geometry to convert them, one in the tangent and one in the normal, okay? Or one in the direction of the impact and one in the perpendicular direction, whatever you call them. If you want to call them z and n, z and y, whatever you want to call them, you can call them. Or you can call them actually x dash and y dash. You can do that. Call them whatever you want. Just a practice, just to know that you know the directions and you know everything. Okay, so right now I was able to know if this is the surface that I'm interested in. And this is the body that is going to hit this surface. And I'm sure if this body, this is the line of impact, and this body is moving that way, I'm sure that the other velocity is going to be something like this. Alright? So, this is the tangent, this is the normal. This is the tangent, and I know that my velocity is something like this, and it's equal to two components. Can you guys tell me the number? And the tangent is, this component is 3.54, and in the normal, this component is 1.99. Okay? If you want to convert this velocity into one in x and y component, like let's say and we said which one is theta. If this is theta, this is going to be theta. So we have this is this one. This is theta, and this is theta. So thing is the other one, and this angle is theta, and the other direction is gonna be like, let's say something like this. This is the V2. This is V1 and V2. So right now I have V2, and I wanna know, for example, the angle between them, like, let's say that this is VA2 is equal to 3.543 in the tangent direction plus 1.993 in the n hat direction. I want to convert it to x and y direction. This is split here. VA2 vector tangent normal. I want to get it VA2 vector I and J. How we can do that? All right. So right now you have the two velocities. Let's remove this part for now. You have these two velocities. You need to convert them to one in the I direction and one in the J direction. If you know that this angle is theta, so basically this and this is 90 degrees, so this is theta, and this, so this is also theta. So you will have to get the components of this in the I direction and the J direction, and this component in the I direction and J direction. I already know that sine theta is equal to 4 over 5, right? And cosine theta is equal to 3 over 5 from here, and from this triangle. So, can you guys tell me what components are in the I direction? So look at these two components. You have component in the tangent, 3.54, and component in the normal is 1.99. If you take the two components, like if you take the cosine component, it's going to be 1 in the J, and the sine component in the I. This one is going to have the cosine component in the I and the sine component in the negative J. So we can put them something here in the I direction, I hat, plus another something in the J hat direction. So basically, let's start with 1.99. Let's see what component in the I. So I can say this is equal to 1.99 multiplied by sine theta, because the cosine is the J, so this is multiplied by 4.5, 4 over 5, plus the component of this one in the cosine, so it's gonna be 3.54 multiplied by 3 over 5. So these two velocities, the one in the tangent, the one in the normal, they give me two components in the I direction. This one has a component in the J, and this one has a component in the negative J. So I'm gonna have the positive one first, so I'm gonna have 1.99 multiplied by cosine theta, which is 3 over 5, minus this component, 3.54 multiplied by 4 over 5. Do you guys understand what I did here? It's just component analysis. Do you guys see the statics that we have on the table before we come here? It's just a bunch of forces, and you get the component of these forces. So here you have a velocity, final velocity in a specific direction. Any velocity, you can convert it in x and y, or you can convert it in tangent and normal. So basically, these two components, I'm sure, you guys tell me, if you have tangent, the tangent component of the velocity is 3.54, and the normal component is 1.99. If I want to draw the direction of the velocity, should be here or here? You have, okay, let's say this is the normal, it's 1.99, which is less than the tangent. So definitely the velocity is going to be much more toward the tangent. So it's going to be something here in this area. So, I mean, like in this direction. Once you can actually get the final V, like you can get the final V is equal to the square root of V tangent squared plus the V normal squared. And once you get V, you found that V is somewhere here. Then you can find the angle and then try to find the I and J component. Okay? So you need to practice the components, how to find the X component and Y component. Like if you have V this way, if I told you try to find the component in this direction, you should be able to know it if you know theta. If I told you there's another dimension this way and this way, you can find the component this way and the component this way if you know this theta. As soon as you know the value of velocity and the theta, you can get the two components. So basically, I can get the V in the direction I and J, or I can get the V in the direction of N and tangent. So you should master this. Like you should be able to do that because that's the basics when it comes to the calculus, right? Okay. All what I'm asking you is just like to go home and try to figure out what did I do in this problem and practice some of the problems that we have in the textbook. And maybe in the homework you have to solve it on your own, okay? I don't mind if you use any extra help to get the answers. Like if you have the answers for the homework problem, I don't mind if you have the answers. But as soon as you understand every problem that you solve, that's what I care about. Okay? That's actually what I used to do. Every time that I want to solve a problem, I want to check the final answer. Okay? So if you use AI or if you use anything to solve the homework, make sure that you understand the problem that you are solving. You are not copying the problem. By the way, homeworks are only 5%. So from 100 points, it's only 5 points. Can you imagine how many points you lost on the midterm? Okay? So if you are not gonna do it yourself, just don't do it. Doesn't matter. We have like 10 homeworks. Everyone is gonna be half point. Okay? I'm not saying this not to do the homework. I'm saying this to do the homework by yourself. Okay? All right, so see you guys after 2 weeks. And if you guys have any problems with the midterm, reach out to me. Midterm is 2 weeks from now. Yeah.
Do I know it?